In this video, I'm going to talk you through another feature of the middle course of the river, two features, which are Meanders and Oxbow Lakes, and I'll try to talk you through both of them at the same time. So what we've got here is we've got the river is now in the middle section. So the important thing to remember is that it's much closer to sea level. So now a lot of its energy is going horizontally, not vertically. Back in the upper section of the river, a lot of the river's energy was downwards as it tried to get to sea level. In the middle course of the river, it can be a lot closer to sea level. So a lot of its energy now moves from side to side. So the Meanders and the Oxbow Lakes are a good example of how we can see an action where this movement is horizontal, not lateral. So in picture one, we have got the river, which is starting to move. In the middle section, geologists and morphologists don't really understand what starts a river off in its movement side to side. They think it could be a band of hard rock that the river's hit and it starts to move away from that. But whatever the reason, this is the consequence of it. So in number one, as we can see, the river is starting to meander. And the river, the energy in the river, rivers are much like roads, and when you go around a road or around a bend in a car, your energy and the water energy gets thrown to the same side. So we'll talk about that as we go through, maybe so you can remember that a little bit better. So we've got some bends here in the river, much as we might have bends in the road. So if we consider that the river is flowing around a left-hand bend, and as it's going around a left-hand bend, the energy will be thrown to the right, much in the same way as if you were in a car and you go around a left-hand bend, then you will be thrown to the right and your energy will be thrown to the right as you're moving around a left-hand bend. So it's the same thing here, and I've shown this on the diagrams as a little striped pattern on the outside of the bend. So the outside of any bend, whether it's to the right or the left, the outside bend will be the bend that has most of the erosion. The inside bend then, because the water's got a lot less energy, then the sediments that are in that water are deposited because the river now doesn't really have enough energy to keep those particles in suspension or keep them moving. So on the inside of the bend, where the energy is less, then the river starts to deposit some of this material. So we've got two things going on here. On one side of the bend, we've got erosion, which is pushing the meander bend outwards. And on the other side of the bend, we've got deposition. So the meander doesn't necessarily, or the bend in the river doesn't necessarily get really big and wide because it's balanced out by one side of it being eroded and the other side of it there is deposition. So it stays not constant, it will change kind of size and shape a little bit, but we don't get big, really wide channels where we've got meanders. We get them looking similar, but the meander bend will get a lot bigger. So if we look at picture two, this is the second stage. This river has eroded on the outside bend and that meander's pushed and eroded out into the floodplain. And you can see again, I've put this little dashed line to represent the erosion. On the inside bend then, remember, that material is being deposited. Any material that's in the water, held in the water or moving along in the water is being deposited. So all that's happening, like I said before, is that this meander bend is getting wider and it's getting bigger. So on the one side it's eroding, on the outside bend, and on the inside bend we've got deposition. And you can see the difference from picture one to picture two is that the bend in the river, or the meander bend itself, is getting bigger and more looped. In figure three, this is where our second feature is going to come in, which is an Oxbow Lake. So I'll talk you through the meander and then we'll talk about the Oxbow Lake. So here, as you can see, this meander bend is now really quite wide. This has gone on over decades and hundreds of years. And the outside bend is now nice and looped, where we're still getting erosion with the striped line, as you can see. And on the inside bend, we're still getting deposition. So we've got the same principles as in the other two, but this meander's now nice and wide. What starts to happen then, that's how meanders form, so we're okay with that. But what starts to happen is, here, as you can see, as the loop occurs, and it comes back around, as the loop kind of is eroded around and then comes back into the next loop, that we've got a smaller and smaller gap here, because this is also, the top bit is also an outside bend. So the river energy as it moves around these bends, remember on the outside bends it always erodes and on the inside bends it deposits. So what we've got here is, this is called the neck of the meander. So I'm just going to write that there. So this is what we call the meander neck. And over time this meander neck will get quite small as the outside bend on either side is eroded and the inside bend we have deposition. So over time, it becomes kind of more and more difficult for the water to travel around. It takes a lot of energy for the water to travel around this big meander bend. And as you can see, as the water comes into that bend, on this outside bend, it starts to eat in and it starts to erode. And as it comes round the meander bend and back into the next bend, as you can see here, then the biggest amount of erosion again is on the outside bend. So over time, this little piece of land here is eroded through because it's easier for the river to flow this way than it is for the river to flow around the big curve of the meander and come back down again. So what happens is this neck of the meander gets cut through and the water finds a much easier route to go from here to here. Instead of going all the way around this bend, it cuts through. When it does cut through, I'm just going to rub it out. What happens is this river now will kind of will come through almost as a straight line now. It cuts out that meander bend, and what's left is the meander bend, and we don't call that meander bend anymore because it's not part of the river. It's no longer a meander. We now call it an Oxbow Lake, and over time this Oxbow Lake can silt up and the water can dry out, etc. But sometimes when it rains, it stays fairly full of water. It stays with some water. When it's rainy, it fills up with water, and so it's left on the landscape as an Oxbow Lake, and the river carries on in a much straighter line, forming meanders elsewhere across the floodplain. But it's now easier for that water to travel kind of straight downwards than it is to go around the loop. And what we've got here is that. So I'm just going to go over this again. The outside bend, we've always got erosion, which is in blue here. The inside bend, we have deposition. So that keeps the meander kind of quite equal, or the channel size, I suppose, quite equal. We've got the meander moves over time across the floodplain. So remember, it moves from side to side. We've got mostly horizontal movement now, not vertical movement. And most of the river's energy is horizontal. And as it's nearer sea level, it doesn't have as much power really to erode downwards because it's much closer to the sea. So most of its energy is side to side. Hence we get these big meanders forming in the middle and towards the lower course of the river.